Hi, everyone. Welcome to a CNCF on Demand webinar. The topic today is how to keep a Kubernetes secret a secret. It's all about secret management from a Kubernetes native way with a project called Trousseau. Who am I? That's a fair question. So my name is Romeo Van de Poel. I'm actually a French speaker. Um, you can call me Ram. I think it's going to be easier for everyone. And I'm currently working at a company called on that. Specialized in persistent storage on Kubernetes. I'm working as a principal architect, and I have the chance to meet a lot of good customers uh, that are starting or are really in the middle of their journey with Kubernetes. Prior to this, I've been working at Red Hat and at NetApp, um, getting a good experience around open source, about automation, OpenShift, obviously, and storage. You can reach me at rom at on that IO if you wish to. So you would ask actually why secrets with Kubernetes, and it's actually another fair questions. One of the main topics that we always have when we discuss with customers whenever is currently with on that or at Red Hat was around security. And some topics like this are really, really difficult to discuss and have a consensus. And one of them, it's quite interesting because it's part of security, but one of these specific topics, it's all about secrets. And for some reasons, secrets are often forgotten. So what I mean by that is that you will have a lot of work around security, storage, networking to make sure that your solution, your Kubernetes platform, your Kubernetes solution is definitely in a good place in terms of security, and you are not exposing an environment in a very dangerous way. But actually, the part of secrets is something that comes later on most likely when you start deploying in production, or maybe actually in acceptance, when you start needing to, you need to start looking into credential for databases in a secure way, or any other type of tokens. Where when you're in development or testing, you might just throw some environment variables and don't really care about it. So obviously, a secret needs to stay secret. You should not tell your secret to anyone. Otherwise, it's news. It's not a secret anymore. Um, and by nature, Kubernetes allows you to have a way to deal with secrets, but the reality is that it's not really secure. It's just all the, I would say, primitives and all the framework to help you deal with secrets. But your secret will be encoded in base 64, and then, well, you will encode your secret in base 64, and then you will store it in the Kubernetes etcd. And that's the moment where it's not a secret anymore. It's ready to be a news, actually, because it's accessible by anyone who has access to your cluster. So just to give a bit of an example of what is actually stored there, you could have credentials for a database or an S3, it could be API tokens, it could be also configuration files, and TLS certificates, well, SSL TLS certificates, and other stuff that can come out along. So um, a lot of different things that can be there and that are really carrying sensitive information. So we assume that with this webinar, you have a bit of an understanding how Kubernetes is working and the different type of objects. So let's not lose too much time on defining those elements, but I will try to do my best to have a common language for this. So let's say that you want to store your DB credentials. The way you don't want to do it it's basically, as I was mentioning before, it's to use the standard etcd with or without address encryption. It doesn't change anything. Uh, and then there's also, I've seen that some images that are flying around on Docker Hub, and I can tell you there's a good amount of them, where the image was built with some credential in to have access to services. And it could be DB, it could be mail servers, or network configuration for switches and stuff. And it's kind of scary. Another way would be also to use a config map or any kind of different configuration file that you would mount from a storage perspective into your pod, which still the same. It's really a bad practice. Um, and yeah, so coming back to the etcd itself, um, there's a couple of solutions that allows you to try to fix this, and we'll look into this, but it's not really helpful. So let's not do any of these solutions here. So after this, you have a couple of things that you can imagine to do, and those are the good things. And all of those elements here have an open source offering. Most likely they might have also a commercial offering if you want to go enterprise and make sure that you have support, like with HashiCorp Vault. You definitely have an HashiCorp Vault enterprise version that help you to make sure that when you have any issues with your vaults, you have someone that can help you. Let's have a look at it. So if you want to use one of those solution called KMS, so Key Management Service, you have a good amount of different options. You have HashiCorp Vault, you have CyberArk with Conjur, KeeWiz, and then you have some more exotic solution like Seal Secrets and External Secrets. And we'll look into this. So just to wrap up everything we discuss here and kind of give a good understanding of where we are with this, etcd is the de facto data store for storing everything that the Kubernetes API needs to deal with and keep recollection of. So when you create anything, it will store in etcd a state of it. So if you create a secret, so basically you will create a value for this in etcd. If you don't have any solution to protect your etcd, because by default etcd is not protected, you will basically have the ability to read what is available in the key value store or the data store of etcd, and it's there. So I will show you after in a demo that it's quite easy to get all the info there. So if you don't have any of the solution we discussed before, the red zone there is definitely the etcd. That's not the way or the place you want to store your secrets. After you have some kind of interesting solutions where you would have an address encryption of your etcd. So basically, what it means is that you will have a solution that encrypt the actual data store, so that you're making sure that everything there is safe and secure. Well, it's a partial solution because actually you can still have access with some trickeries, and it's proven that it's a good first step, but it's not the best way to do it. Then we have interesting project, and that's what I was mentioning before, like Seal Secret. Seal Secret is an interesting one because I had a chance to implement this and work around the architecture for a major project back at the time I was working at Red Hat. And the overall is quite interesting because it completely bypassed the etcd and the API manager, although there's some usage of the API manager, but still it's a bit different in the way it's working. And what it does is that you will need to have Git somehow, somewhere in your environment. And you will have to deploy a controller on your Kubernetes. And the controller basically will act as a solution to encrypt to seal your secrets. The way it works is that it uses a key pair approach where you have a public key and a private key. And using those two elements, you will be able to encrypt your secret, seal your secret, and store your secret in Git. And when you need to have access to your secret via the creation of a seal secret CRD, you will be able to actually decrypt your secret and have access to that secret for your application. It's quite complicated, right? It is. And one other thing that it's quite complicated is to make sure that from a usage perspective, you have a good understanding of what you're doing, and you don't introduce a human usage of it. And the reason why I'm saying this is because during the implementation of the solution, we have seen many situations where when people were committing their secrets into Git, they were committing both the secret.yaml and the seal secret.yaml. So in this case, you just have you just record it in your Git your secret, and Git is a revision solution, so service, sorry. So it means that it's going to be there forever. You will need to get rid of the branch, or maybe even the master. You already committed the master, and then to make sure that you don't have access to that file anymore. So that's quite a dangerous thing. Although it's an interesting one, but only if you're using a pipeline. So to make sure that you don't have that error-prone situation. Uh, so good, but kind of complex. Then you have I would say the kind of solution based on KMS, so the key management service, which is perfect when it comes to applications. And what I'm saying, the reason why I'm saying this is because it's a bit like also the other solution. It doesn't look into leveraging the Kubernetes API. It doesn't look into the etcd. It has its own engine um, where you can store the different secrets and different type of secrets. You can have key value stores, you can have tokens, you can have um, typical credentials. And yeah, in that case, it would be more like a key value store. But so you have multiple different engines. GWT, for example, would be one also. So you can create based on this a different type of authentication. And the way it works is that when your application wants to have access to the secrets in the vault, you would have like a sidecar. So it's like a tiny containers that will live with your application that is trusted by the actual KMS. And that's the only entity with your application that will be able to fetch the secret and feed that secret to the application. That's the only way to do it. From that standpoint, obviously there's other approaches, but the best way to do it, it's there. And a good example for this, it's the Vault agent for HashiCorp Vault, and it works like this. So the agent is going to be the sidecar. It will live in the sidecar, connect to the HashiCorp Vault, retrieve the secret for the application, and feed the secret to the application to access maybe a database or an S3 endpoint or whatever the application requires. I want just to do a shout out to HashiCorp, by the way. We had the pleasure to have a good discussion around Crusoe in the project, and they gave us a good feedback around how to use the sidecar for our Crusoe project too. So we'll have that in the next implementation. That's going to be fantastic. So speaking of the devil, Crusoe is a pretty good approach if you want to keep using your Kubernetes API the native way, and you don't want to have an extra set of CLI. and you don't want to come up with the need of learning a new thing or creating new workflows or having multiple solutions, because the KMS will be perfect for your applications. But if you have solutions that are not capable of having a sidecar attached to them, like for example for storage, then you will have an issue because you will not be able to attach a sidecar to a persistent volume for encryption and retrieving the encryption key, for example. And in this situation, you will need to rely on or leverage the Kubernetes API to do so. So it's a situation, and that's why I put on this diagram both. I put the usage from a low-level Kubernetes resources, and also you can still leverage your KMS for your applications for that support sidecar approach. So this is a pretty versatile, agile way of doing things, and it really reduces the amount of, I would say, constraint from a technical standpoint that you might have when you deal with secrets. So how does it work? Well, it's really easy. Think about it like uh, every simple usage of a kubectl to apply a configuration file like a secret here that will go through the API. And when it hit the API, what happens is that the API has a specific configuration that says you need to talk first with Truso before registering your secret in etcd, the values of that the secret itself. So what happened at that stage is that Truso will communicate with the KMS. In this example and the demo, it's HashiCorp Vault, and we will look for a transit key. The reason why we do this is because we don't want the secret to go back and forth through the network to the wire. We don't know where the vault is. It could be one of the vaults running in AWS from the HashiCorp Vault, the HashiCorp cloud platform. And in that case, you don't want to have too much information transiting back and forth in over there, especially if you didn't put any VPC inside. So we fetch the transit key. We verify that we are allowed to do all the transactions, and at that stage, we do what we call it encryption using envelope scheme. So basically, we will take the actual secret that we have, those value there, we'll envelope that into a capsule and protect it with that token that we just got, the transition key actually that we got from Vault. And when we have everything together, we will store that in etcd and make sure that it's available for every application that needs to have access to it. So this is the high level overview. It's quite actually just how it works, and nothing trickery around this framework. And actually, it's a well-known framework from Kubernetes. Kubernetes implemented the Kubernetes MS provider framework to allow that usage and to leverage the Kubernetes API while you can still have access to a KMS to have that um, encryption of your secrets and make sure that everything is secure and available in etcd. The good thing also is that you will make sure that you can always use the very same tooling, and you don't need anything extra. It's just perfect for that solution. And still, if you want to continue using your sidecar for your application and retrieving secrets in HashiCorp Vault or any other KMS, you can still do it. That's the beauty of the solution. Also, for the moment, we're looking into securing only the secret as a resource in Kubernetes that is stored in etcd. In theory, we can basically secure everything, every type of resources in etcd with this approach. All right, it's time for a demo. Let's see. So first of all, I just want to show you the web page. Very simple. We are all about simplicity. Um, it's trousseau.io. Trousseau is the French word for keyring, actually. And we have a nice Git repo here with everything in there. And there's a wiki to explain you how to deploy the solution. It's quite straightforward. I will invite you to go through this and have a look. It's not really trivial to do that. So then what you need is a vault. In this case, we're using a development environment from the HashiCorp cloud offering, deploying on AWS. And we have actually this vault available here, and we're using the namespace. Yeah, we're supporting namespace too for enterprise solutions, the enterprise offering of Vault. And we have a transit key too here. And if we look into this, we have a couple of them that we created. All right, so now let's have a look here. First of all, if we want to look at the how it looks like, um, it's quite easy. I just need to do this. And we have actually, as you can see, we have three pods, and the three pods are um, from a daemon set. So if I do all and I do a grep of vault, you would see that it's deployed as the daemon set. So daemon set allows you a good thing here is to make sure that there's always the necessary amount of Vol KMS pod running. And here we're looking at least at one pod running per master. So the way it's working, as I was mentioning earlier, we need to have a configuration file that says to the API manager, in here we're running a Rancher. So if I look at the configuration file from librancher, RK2, server, credential, and then I have a configuration file here, which is basically telling the API server when you see this kind of resource, the secret resource, go through a KMS, and here are the information on how to access this. This is basically linked to the pod here, those pods, and it's a socket. It's a network socket, and the transaction occurs there. From a configuration perspective, what we have is we have also a configuration file here that says, here's my demo token test key name, the address of my vault, and the token. For those who want to try, this token will be, there's a TTL in it, so you can try to connect to the URL inside, and it's not going to work. One thing though, that's where the sidecar is interesting, is because in this case, we would remove that concept of having a configuration file, but having just a sidecar attached to all the different pods that would feed those information before the need to expose a configuration file. So thank you, Ashiko, for this. We'll definitely look into this. All right. So and then obviously, and I'm just going to mention, first of all, this cluster currently is not having any encryption set. It's using the basic one. And if we look at the actual file, and bear with me here, because here we go. You can see that there's a zero identity. It's totally different than what we have here. We don't have the KMS part and so on. So in this situation, if I just do and I have some scripts here. I have two secrets that I can create here. If I do echo -n of my secrets, yeah, it's the secret that we're using for on that for our storage OS offering. Oh, I did not have. Oh, yeah. Bear with me with this. So um stupid me. That's the pleasure of doing a demo. It's -d. As you can see, the actual secret is storage OS. That's the default API secret for our on that offering. So anyway, it's not the most important part here. So what I'm going to do here is I'm going to just execute this. And what it does is that it's creating a secret, as you can see. We're creating a namespace called secret1, and we're creating a secret called secrets. And then I'm fetching from the etcd the information in the registry. So I'm just targeting the registry for that part. And as we can see, this is the basic information when it's not encrypted. And I have information about everything. I can see also that I have my value here. This is the value that we used, right? So if I recall this, as you can see, it's exactly the same. And just to make sure that it's the same, just going to copy paste it and see that it's indeed storage OS. So this is bad. So the way we can change this is to say, I'm going to do this here. Um, I'm going to do a VI, and it's specific to our Rancher here. So I'm using a Rancher cluster. So um, I will go in the configuration file and say, I want to use that specific file that you configured for using the KMS. And actually, I will need to do that on all the masters. So, here we go. Here we go. And then we do execute systemctl restart of the RK2 service. So here we go. And what we're looking at is basically we want to make sure that when we do a grep of the encryption bits, it's not yet changing. So let's see. The API manager is coming back. So that was the previous value. The API just stopped at some point, the API manager, and it restarted with the API server. It restarted with our configuration file. In this case, if I execute my second use case, and I do this, so I'm going to create now a secret named secret2 in namespace secret2. So that's what I created. And I want to fetch the information about it. As you can see, it says here that it's encoded with Vault provider. And we have the Vault and the version of the API that we have been using. And everything else is just encryption. So that's how you can easily secure your secrets without too much difficulties, without too much of a hassle, and using standard API. All right, so demo is done. It's straightforward. It's not shiny. It's just working. And what I'm gonna look for is a call to action. So keep your secrets. Join us on the Truso project to contribute. The repo is over there. So just, well, not the repo, but the organization is over there. Just come, have fun. We're looking into implementing many other KMS because we want to have it universal and available for as much solution we can. And well, yeah, let's be contributor for the open source, for the greater and the good, you know. Thank you.